Hello everyone, my name is Guduru Yagnesh. I am a machine learning intern from Data Science Academy at Sai Chamundeeswari Academy. As a part of my internship, I have been assigned to do a project titled as music recommendation system, which in which we have worked as a team. And our teammates are Harshit, Rakshit, and Mahendra. At, at the beginning of our project, we first thought a question like, why a recommendation system? A recommendation system which provides a best and efficient solution or a recommendation which provides the improves an efficiency of an app. And then our music recommendation takes that which recommend our music recommendation is used to recommend a best similar songs for the user based on his input. Our task is to take input from song like song name or a feature from user, and where we our music recommendation predicts the best similar song of the user based on our previous data. For developing this project, we have used some datasets which were sourced from Kaggle, and these are the datasets that we have used. In which that data.csv is the main dataset which contains the song names and all those things. And then we have a different datasets, so we have divided our work to work on different datasets, and this is how we divide our tasks. In that data underscore genre.csv is my task to develop, where I use a genre to recommend a song for the user based on his input. And before starting the project, we have studied some research papers like the top three we have given here: evaluating a recommendation system, explainability in music recommendation system, considering emotions and contextual factors in music recommendation system. Not only this, we have searched in browser, and also we have watched some YouTube videos to get an idea of how to build a music recommendation system, how to make it an efficient system. And then what we have learned from this project is how a machine learning project works in real world, and how a recommendation system works, and how to build a model based on the data that we have, and some of the algorithms from in the machine learning, and some Python libraries to build a machine learning. Now I'm going to show my code, and before that I will see the dataset that we have used. This is the main dataset that we have used, in which have a column name which represents the song name, and some of the columns like acousticness and danceability which represents the features of the song. And my dataset which I have worked is data by genres, which have the main column is the genres name, and some of the features like acousticness, danceability, same as in the main dataset. Based on this dataset, I have built my model. Before, at the beginning, I have imported a NumPy, Pandas, Matplotlib, PyPlot, Seaborn, SNS. First, I have imported my datasets like data as a data.csv as a data by genres as a data genre. This is the dataset, the main dataset data, and I have no null values. And this is the genre dataset that I got, and it is also have no null values. At first, I have thought of doing a clustering or use a clustering algorithm. For that, I have filtered some main features of the genre or a song to relate both songs and genres. So these are the features that I have filtered. As a part of a clustering algorithm, first I filtered the numeric data of my genre, and then using the standard scalar scalar.preprocessing, I imported the standard scalar, make and scale the data, standardize the data, and then using a k-means clustering, I have clustered the data sets. I have used 10 clusters, and these I have when I clustered, I got a cluster labels. So these cluster labels to represent the genres. So I have added one more column in my genre dataset, and in the end name it as a clusters, and I have used which I have a multiple number of columns, so which will make me like uncomfortable to draw a graph or something. So that's why I have reduced its dimensionality. So sklearn.manifold, from sklearn.manifold I imported tsne, which reduces the dimensionality of my scalar data, and then this is the reduced dimensional value of my data. From that I have drawn a graph from plotly.express as scatter plot. This is the clustered graph of a genre. Similarly to the songs, I have done the same process by using standard scalar, and here I have used a PCA, principal component analysis, to reduce the dimensionality of the data, and this is the clustered graph I got from the songs. Now I found out the cluster values and how the songs are different durations. Now I have tried to build a model to recommend a songs based on genres. At first, I thought of using a cosine similarity because I have no column called genre in my main data. So I have to find a similarity between the song and the genre based on the similar columns like acousticness, danceability, which are the song features. So at first I imported a cosine similarity, and then I started to build a model. In the beginning, I used it as I found based on I have given an input as a song name and found out the what are the song features and filtered and stored it in a song values. And then as a process of cosine similarity, I have to iterate through genres dataset for finding a best genre for that given song. So in that I have used a for loop for the data genres, and then in that for loop I have at first find out the present role call genre values, and then use the cosine similarity to find the best match according based on those two features like song values and genre values. After finding a best genre, I have stored it in a song genre, and then based on that genre I have found the now I have set it in the main data set for finding the best songs for the genre. This is the code that I have used. Here is I have given an input called Clancy Lowered the Moon, which is a song name, and I got the best top 5 songs which are related to the same genre, like Portuguese early music and piano concert 3, likewise. What if my input is a genre? For that, I have used a similar process, but here first, I take a genre name as an input and extract the its features, and then match it to every song in the main dataset, like I have done it earlier. Here, I have given an input called a cappella, and I got the top 5 songs that are based to a similar genre. This is my model, which is gives a best recommendation based on its genre. And when it comes to a mood based recommendation system, we all 4 members of our team are worked together and shared our thoughts and matched our codes and works. Here is the mood dataset that we have used, where I have imported an NumPy and pandas and read the mood data and main data. Actually, in my main dataset, I have no any column named as det mood. For that, I have a dataset called mood data, which have a column called mood. From that, I have taken a mean values of those features, main features that I have to compare. For that, I have used the mean values. Here is the mean values of every mood that I have in my dataset. And then I have clustered the mood dataset, and similarly to the genre based recommendations that I have done earlier, and for all the songs which I have in the main dataset, and then based on those average values or mean values, I have built a we have built an mood recommendation system, which takes a song name and as an input and finds the mood value of that song, and then compares each and every song in the main dataset for the which are related to the same mood and extract the top popular songs to the given input. This is the code that we have developed for the mood based recommendation system. Similarly, we have taken a song name as an input and extracted the song features and then compared it with the mood features and find the best mood suitable for that song, and then compared with every song that I have in my data, found the best songs here. I have given a top song as a input as a Clancy Lloyd the group. I got the top 5 songs which are related to the same mood of the Clancy Lloyd group. What we also thought of, what if a mood has an input? So this is the code that we have developed for the input as a mood. It takes the mood value as an input and extracts its features and then compares it with the every song and finds the best similar songs for that mood. Here I have given a mood as a happy. So for that I got the top 5 songs for that mood. This is the model that we have developed in our as our project as a music recommendation system. Thank you.